Hello. In this question, A voltage at A is less than voltage at B. So, this diode P region at lesser voltage and N region at higher voltage. So, diode is at reverse biasing. Means resistance is quite high and it will not work. So, acting like open circuit. Ideally, finite resistance open circuit. It means resistance between A and B is only lower one. So here it is only 20 ohm because ऊपर वाला तो infinite हो गया. So option here is 2. In question 22, barrier potential is 0.3 volt and depletion width is 1 microampere. So electrical field here is voltage divided by tensor gap. So 0.3 divided by 10 to the power 6, 10 to the power 6 होगा 10 to the power 5. 10 to 10 power 5 volt per meter. So option here is 2. In conductor, conduction is because of electrons only, but in semiconductor, conduction is due to both holes as well as electrons both. So option is correct because electron and holes both are responsible for the current conductivity. In this question, wavelength is given as 589 nanometer. The band gap energy. So this is as C by lambda in joules, at C by lambda E in electron volt. Putting the values here 6.62 into 10 to the power minus 4 C speed of light, lambda 589 nanometer, electron charge is 1.619. Solve it here, it comes to 0.1 electron volt. So option 2 is correct. Hello, in this question, N-type semiconductor. We are getting N-type semiconductor. In pure semiconductor, intrinsic semiconductor, we are adding the impurity atoms, donor atoms. So pentavalent impurity atoms. And after this, N-type semiconductor is something like that. Conduction band and the valency band. Energy between conduction and valency band is 1.1 electron volt for silicon and 0.72 for germanium. And the donor energy state, pentavalent energy state is somewhere here at a gap of only 0.01 roughly electron volt. This is the donor energy level just below the conduction band. So option here is 2 correct. In question 26, full wave rectifier DC voltage output here is 2 1 pi into maximum voltage for full wave rectifier. So 2 upon pi to 20 is RMS value where root 2 and the transformation ratio 1:2. That's why here in the output comes 2 because of this primary and secondary 1:2. So voltage secondary is double of the primary of this transformer. Transformer output is double. That's why 2. We solve it here 80 root 2 on 3.14. So it comes here after solving 36. Here option 3 is correct. Hello, in this question we are getting the current as well as conductivity both depends on electrons and holes both. So here conductivity is given by mu E Ne mu H holes and H for holes. Mu means mobility and N means density. So this E electron density, NH is hole density into E. We put all the values here. Here Ne is equal to NH. Both are same in the question given 3.6 into 10 to the power 19. So we are taking it common 3.6 into 10 to the power 19 mu 54 plus 0.18 into E. E means electronic charge. We solve all of this. We are getting here 4.14 Siemens per meter. So this is the conductivity and option 1 is correct. Here in this question 28, drift current in reverse biasing 20 microampere, that is very less. The voltage drop or potential drop in 15 ohm is also very less. It means all the voltage 4 volt of the battery comes across this diode. The approximate voltage across this diode is roughly 4 volt because voltage drop here in this resistance is negligible. So option 3 is correct. In this question 29, here at the P region, this voltage comes here plus 2, and N region this voltage comes here plus 5. So it is reverse bias. In reverse bias, almost no current flows in the circuit. No current flows in the circuit. So here current through voltage 0, current is 0, option 1 is correct. Hello, in this question, this is the conduction band and valency band, and the gap between them is 1.1 electron volt for silicon, but due to the temperature increment, some electrons excited by the temperature and some electrons are reaching to the conduction band because of the temperature. It means effectively energy gap initially this, but because of temperature some electrons are reaching to the conduction band. So effective energy gap is reduced at temperature T. The original gap minus something. Do not know the exact relationship, but here in all the cases one may be correct, but 0.7 volt, 0.7 for silicon, not for germanium. So only for germanium 3 and 4 options are there. But it say if it is plus, it means electrons are reduced, but in increasing conduction band, only possible option is. Hello, in this question, say that 0 volts and this is minus 10 volts. Somewhere here, it is says somewhere in between 0 and 10, minus 10. So, because of the biasing, D2 diode is forward bias and D1 is reverse bias. It conduct, but it will not conduct. Ultimately, they are in series, so this circuit will be behaving like open circuit. It means D2 forward, D1 reverse bias, so there's no current flowing. Current flowing, the circuit is 0. So option 2 is correct. Now in this question, in forward biasing, table voltage and current given, for reverse also. So here forward biasing resistance given as change in voltage divided by change in current at milliampere. So it is 0.4 divided by 20 into minus 3. It is 20 ohms. And the reverse biasing 0 minus 2 only 1.5 microampere means here 8 into 10 per 6, 8 into 10 per 6 ohms. So option 3 is correct. In this question, pure silicon semiconductor is doped with boron. This is pentavalent impurity atom. Pentavalent impurity atom, donor atom, it donates the electrons. In this question, pure semiconductor, it is doped with boron. Boron is trivalent impurity atom. Sometimes it is called acceptor atoms, trivalent atoms, acceptor atoms. Accepting the electron means deficiency of electrons generating holes. Positive type, that is why it is called type semiconductor. If it is doped with germanium or silicon doped with boron, it is P-type semiconductor. So option 4 is correct. Hello, in this question, this is positive, negative. So D1 diode, reverse bias, it will not conduct. But D2 diode is forward bias, it conducts. Is not ideal. So resistance of D2 diode is given in the question 30 ohms. So this circuit becomes like here this is 30 ohms and this is the 70 ohm resistance. This is 50 ohm voltage of the battery 3 volt. So current here in this is 3 volt divided by total resistance 30 plus 70 plus 50. So this is 3 by 150 or 1 by 50 will be 0.02 ampere. So option here is 3. Hello, in this question we know Ni intrinsic concentration for pure semiconductor or intrinsic semiconductor. It is given as 6 into 10 power 8 per meter cube, and electron concentration by doping that comes here 9 10 per 12 per meter cube. So we have to find out the whole concentration. The formula NH into Ne equal to Ni. So NH will be Ni square divided by Ne Ni means 6 in 10 power 8 to 6 in 10 power 8 on Ne 9 10 power 12 means 2 4 10 power 4 per meter cube. This is the whole concentration. Option 3 is allow in this question 37. Terminate mechanism for the motion of charge carriers in forward and reverse bias in PN junction diode. In reverse bias, mainly diffusion of majority carrier responsible. In reverse biasing, drift current, drifting of charges of minority carrier responsible. So diffusion in forward biasing, drift in reverse biasing. So option 2 is allow in this question. In pure germanium, pure semiconductor, maybe germanium, maybe silicon, in pure semiconductor, intrinsic semiconductor, both concentrations are equal. Sometimes call it is intrinsic concentration. So option 3 is correct. Hello. In this question, we are getting the output DC, input AC. Hello. In this question, in AC input and DC output for positive half cycle, positive, it comes here like this. This is the path, and negative cycle comes here, so output. For negative half cycle, negative respect to positive, so negative comes here and positive half cycle comes here. Like say, so this is input AC and output DC. Across the resistance, direction of current is always like this. So we are getting the output for positive and negative half cycle. This way we are getting the output AC. So option 4 is correct. Hello, in this question you have to find out the forward biasing. If it is P region positive or at higher voltage, then any region negative or lower voltage, that is forward bias. Otherwise it will be reverse bias. So here P region, case of 1, P region is -5 higher voltage than N region -10 volt. It is forward biasing despite both are negative. But positive negative is not doesn't make any difference. P region must be higher than N region. This is forward bias. So here only circuit is 1. So option 1 is forward bias. Otherwise P region here is 5, 10, so reverse bias. This P region -10, 0, so reverse bias. -5, 0, reverse bias. So only option 1 is forward bias.